Today we're going to learn about set notation. Now, to remind you about set notation, I'm going to take you back to Venn diagrams. So a set is some data that might be included in the Venn diagram. So let's just do an example straight up. Let's suppose set A contains all the odd numbers up to, say, 9. Now let's suppose we've got a second set, set B, which just contains the numbers up to 5. So 1, 2, 3, 4, and 5. Now, you'll notice that I've used some brackets to indicate the sets. So set A is written with some brackets and set B is written with some brackets. Now, let's have a look at how we draw a Venn diagram. So usually, it's enclosed within a rectangle, and we use the letter E that stands for all the elements that are involved in this Venn diagram. So all the elements with A and B are all these numbers within these sets. Let's just do set A here. And set B. Now you'll notice there's an overlap here. This is what we call the intersection. So if I was to fill this in, what numbers are in both A and B? Well, we've got 1 and 3 and 5. So in our intersection 1, 3 and 5 will go in there. Now what's just left in A is 7 and 9, and what's just left in B is 2 and 5. Let's look at the symbols that we might use then to display this intersection. If I want to use A intersect B, I'm using this symbol here. It's like an N with no stick. It means intersection. What that refers to is what numbers within this set, or what elements in the set, are contained in both A and B only. So we would write that as 1, 3, 5. Then there's the other thing called union, A union B. That basically means give me all the elements of the subset, or the set, sorry, that are in A or B. So if we look at all the things in A or B, that's everything, because every number is either in A or B. So I'm going to write 1, 2, 3, I've missed 4. 4 should be in there. I've written 2 and 5 instead of 2 and 4. That's alright, I'm allowed to make a mistake. So 1, 2, 3, 4, 5, 7, and 9. Okay? Now, the only other thing that you might need to know is if a set contains a subset. And a subset means you're going deeper into one of the sets. And often it's just a little circle inside the circle. So this would be the subset of A. Now, I haven't put anything in there. The symbol that's used for subset is like an intersection on its side with a line underneath. Now we don't just use Venn diagrams with set notation. Set notation is also used to describe the domain of a particular function that we might be looking at. Domain is all the x values that work for that function. So let's just talk about some of the other types of numbers that we get. The symbol R, and I put double lines down the R, so capital R, represents all real numbers. Okay, now what we're talking about is every single number that we know in our number system. There is a second number system, which we don't study in maths methods, called complex numbers, the imaginary number system. So we don't use that. So any real number is any number you've ever heard of, such as a fraction, a decimal, or a any integer numbers. However, we can go into a subset of those real numbers. We can use a letter to describe the integers of those numbers. Now, integers are denoted by the letter Z. Okay, now, I put a cross through my Z. It's a capital Z, but this is all integers. Integers. There we go. Okay, integers. Now, we also describe other numbers within the real number system, such as rational or irrational numbers. So rational numbers are numbers that follow a pattern that we can easily predict. Terminating decimals are rational numbers. We also have irrational numbers. Irrational numbers are numbers that we can't predict, that behave erratically, I guess, like pi. We know pi to a few decimal places, but pi is continually changing. There is no set pattern. Other irrational numbers that exist are the natural number, E. E is an irrational number. So let's write down what those symbols are. So rational numbers are denoted by Q, and we have irrational numbers denoted by other one that we have are the natural numbers, which are represented by the letter N. Now let's also look at some more subsets of these real numbers. We have positive real numbers, and it might be that if we're describing what numbers work for a particular function, it may only be positive real numbers. Or we have negative real numbers, so you can separate real numbers into positive and negative as well. Let me give you an example of where we might use that and how we might use the set notation. If I was to draw the graph of y equals x squared, for example, a very basic one, we know that that parabola continues infinitely in that direction and infinitely in that direction. So that means that all these x values that I can put in would work, and all these x values that I can put in would work. So we would say that all the x values, the domain of this function, belong to R, all the real sets of numbers. Obviously, we don't need to define the subset negative or positive because it works in both directions. So we would use this belong sign and all real numbers.